Welcome to EduRev.
Have you ever wondered how we get that molten iron which is used to join cracked railway track together? Come, let's find them out. In this video, we will understand what is a displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Let's first understand a single displacement reaction. Here, A reacts with BC, giving AC and B. In this case, A seems to be quite strong and seems to be pushing out, or rather displacing B from BC, thereby forming a new compound AC and setting B free. So, when we mix aluminium with ferric oxide, aluminium displaces iron from ferric oxide to form aluminium oxide and setting iron free. Please note, this reaction is performed under specific conditions not mentioned in the above reaction. This is one way of obtaining molten iron. Shall we visit the lab and perform some activities to understand our concepts better? Word of caution: you are advised to perform all laboratory activities under the guidance of your teacher. Okay, here you have 2 iron nails and a copper sulfate solution in a beaker. Let's get our inquisitive mind out and find what happens when these 2 reactants mix with each other. Let's pour the copper sulfate solution in equal quantities in 2 test tubes, about 10 ml in each test tube. Clean the nails well with a sandpaper to remove the surface impurities. Clamp the test tube B containing the copper sulfate solution. Introduce one of the nails with a thread into test tube B. The second test tube containing pure copper sulfate solution can be kept in a test tube stand. Keep aside the other nail on a watch glass. Now, keep them undisturbed for about 30 minutes. The displaced copper deposits on the iron nail, forming a reddish-brown coating. What can we infer from this? We can infer from this experiment that iron seems to be more reactive and displaces copper from copper sulfate solution, thereby leading to the fading of the blue color of the copper sulfate solution. Let's try another experiment. Take about 10 to 15 ml of silver nitrate solution in a beaker and insert a copper wire. Keep it undisturbed for some time. Look here, what's happening? We can see some white particles falling off, and the color of the solution also seems to be changing from a transparent to a bluish color. In this case, copper seems to have displaced silver from silver nitrate to form copper nitrate and setting silver free. Aha! Now I can make some silver jewelry out of it. So, how do you know which element is more reactive than the other? Not that difficult. Here is an activity table that you need to refer to find out your answers. Both metals and non-metals take part in displacement reactions. From the activity series, it will be seen that a more active element will displace a less active element from a solution of its salt. Now, let's look at what is a double displacement reaction. Reactions in which 2 compounds react by an exchange of ions to form 2 new compounds are called double displacement reactions. In case of a double displacement reaction, AB reacts with CD to give AD and CB. Let's perform one more experiment. In a beaker, take about 4 ml sodium sulfate solution. In another beaker, take equal amount of barium chloride solution. Now it's time for mixing. What do you see? Looks like there's a white color precipitate which is formed and is insoluble in water. Such a reaction leading to a precipitate formation is called as a precipitation reaction. In this case, the white color precipitate of barium sulfate is formed by the reaction of barium and sulfate. The other product, sodium chloride, which is formed, remains in the solution. Did you know? Mixing of magnesium with copper sulfate solution is a single displacement reaction. Mixing of lead nitrate with potassium iodide solution is an example of double displacement reaction. Now that we have come to an end of this video, let us quickly summarize your learnings. In this video, we have learnt single displacement reaction, double displacement reaction. Now that you have understood single and double displacement reactions, you might want to verify your understanding of the concept and revise the chapter. You can attempt tests, see videos, and read documents through our exclusive EduRev Infinity program. We have 800 plus videos, 2500 plus documents, 6000 plus questions across the subjects waiting for you to practice and master the concept. With EduRev Infinity, you can access every primary subject of your class. Thanks for watching.